Let's take a look at our next example, example 3. Determine the perimeter of the figure below. So we have seen this before, it's just a different twist here. So we have, what two shapes do we have here? We have a rectangle and a triangle. So we can find the perimeter of the rectangle, and by the way, you may pause and try to figure out yourselves. We are able to find the perimeter part for the rectangle. So this would be 3, this would be 5 centimeters, this would be 3 centimeters. So we know we already have 11 centimeters. But now we need to find this. Now, these two side lengths. Now, these two side lengths are the same. And what type of triangle do we have here? It's a right angle triangle. So, let's draw this triangle here on the side. Right, just do a sketch like that. And this is what we have here. The dotted line. Those are 90 degrees. That's 90 degrees. These two side lengths are the same. Do we know the length of this side length? Which, by the way, we know right away that this side length would be the hypotenuse, because it's opposite the 90-degree angle and it's the longest side. Well, what's the length of this side? If you study the graph, we can see that it is 5 centimeters. Now, how do we find these two side lengths? Because those are the side lengths that we need to count. And luckily they are the same. Now, if we have a right angle triangle, if we need to find the side lengths or the hypotenuse, we use which formula do we use? Well, we use the Pythagorean theorem. C squared equals A squared plus B squared. Right? Let's label C. C would be the hypotenuse. Good. So this is C. All right. This would be A. This would be B. However, do we know what the length of A or B is? No, we know that they're the same. So what we can do is let's just call this X, and we can call this X. I know you're thinking, well, what's the difference? Just another variable. But let's take a look at this, and let's apply it into this formula, into the Pythagorean theorem. So let's substitute the values. So for C squared, we're going to write 5 squared equals to, instead of A squared, we're going to write X squared plus, instead of B squared, we're going to write X squared again. Well, we have 5 squared is equal to, what is X squared plus X squared? If you remember collecting like terms, what are like terms? Like terms have the same base and the same exponent. They have the same variable and the same exponent. Same base, same exponent. So X squared plus X squared gives us 2x squared. Alright, so now what we can do is this. What's 5 squared equal to? Is equal to 25 equals 2 squared. So now what we can do is solve for x. Let's move the 2 to the other side. So that becomes 25 divided by 2. It's equal to x squared. What is 25 divided by 2? It's equal to 12.5 equals x squared. And now we need to square root 12.5 in order to find out what the value of x is. 12.5. So x is equal to square root of 12.5. What is the square root of 12.5? Well, that's equal to 3.54 centimeters. This means that this length here is 3.54 and this is 3.54. So let's label it here. Actually, this is 3.54 centimeters. So now we know what the perimeter is going to be. The perimeter is going to be equal to, let's label this like that, to 3.54. So 3.54 plus 3.54 plus, so we're going this way, plus 3 plus 5 plus 3 plus 3 plus 5 plus 3. And what is this going to be equal to? Well, if you add these two, you get 3.5, that's 7.08. 7.08, and then 3 plus 5 plus 3, that gives us 8 plus, well, 11 plus 11. Then you add these two, 7.08 plus 11, that gives us 18.08. 18.08, I almost wasn't able to fit it in, centimeters. So that's the perimeter of this shape.